Welcome. Have you ever wondered what the next great leap in technology will be? Today, we're diving deep into one of the most exciting frontiers of science, quantum computing. You might have heard the term thrown around, but what does it really mean? What can it do? And most importantly, why does it matter? Traditional computers have revolutionized our world for decades, from personal laptops to massive data centers. But what if I told you there's a new kind of computer emerging, one that could make today's technology look like a child's toy? Quantum computers. What is quantum computing? At the heart of quantum computing lies something very strange: quantum mechanics. Quantum mechanics is a branch of physics that deals with the behavior of the smallest particles, things like electrons, photons, and atoms. These particles don't behave like anything we encounter in our daily lives. They can be in multiple places at once, travel in unpredictable ways, and even be connected in a mysterious way across vast distances. In the world of quantum computing, this strange behavior is harnessed to process information in ways classical computers simply can't. But how? Well, let's break it down. Classical computers versus quantum computers. Classical computers, the ones we use every day, work by processing information in bits. Each bit can either be a 0 or a 1. All the work a classical computer does, whether running apps, browsing the internet, or performing complex calculations, relies on strings of these zeros and ones. Now, imagine if instead of just being a 0 or a 1, a bit could be both at the same time. This is called superposition, one of the key principles in quantum computing. This allows quantum bits, or qubits, to process more information simultaneously than classical bits could ever dream of. Scene 3. Superposition and qubits. Superposition is like flipping a coin. While it's in the air, the coin is both heads and tails at once. It's only when it lands that you see the outcome. In quantum computing, qubits exist in this kind of dual state, both 0 and 1 at the same time, until measured. This means a quantum computer can process an exponential amount of data compared to a classical computer. But there's more. Another key concept is entanglement. Entanglement, a mysterious connection. When qubits become entangled, they are linked in such a way that the state of one qubit instantly affects the state of another, no matter how far apart they are. This entanglement allows quantum computers to perform complex operations in parallel, making them exponentially faster than classical machines for certain tasks. Entanglement and superposition are the building blocks of quantum computing. Together, they enable quantum computers to solve problems that would be impossible or take millions of years for classical computers to handle. Quantum speed and power. So why is quantum computing so powerful? It's all about the speed and scale of computation. A classical computer must go through every possible option one by one to solve a problem. A quantum computer, on the other hand, can evaluate all possibilities at once, making it exponentially faster for certain tasks, like simulating molecules for drug discovery or optimizing large systems like traffic patterns. The quantum advantage, real-world applications. Let's explore some real-world applications. Quantum computing has the potential to completely transform industries. For example, in drug discovery, researchers could use quantum computers to simulate complex molecular structures and reactions at an unprecedented scale, speeding up the development of new drugs and treatments. In cryptography, quantum computers could break today's encryption methods, but they could also create entirely new, unbreakable encryption protocols, making data security more robust than ever. And when it comes to AI and machine learning, quantum computing can process and analyze data in ways that classical systems can't, leading to advancements in everything from facial recognition to self-driving cars. The challenges of quantum computing. It all sounds incredible, right? But quantum computing isn't without its challenges. For one, qubits are extremely fragile. They can easily be disturbed by their environment, causing errors in calculations. This is known as quantum decoherence. To make quantum computing practical, we need to maintain the delicate state of qubits long enough to perform meaningful calculations. This requires specialized environments like extremely low temperatures, and even the smallest disturbance can ruin an entire computation. Researchers are working on improving quantum error correction methods to address these issues. But for now, building stable, large-scale quantum computers is a huge hurdle. Scene 8. The current state of quantum computing. Currently, quantum computers are in the experimental phase. Companies like Google, IBM, and Rigetti are developing quantum processors, and several breakthroughs have been made in recent years. For example, Google's 2019 achievement of quantum supremacy demonstrated that their quantum computer could solve a problem faster than the world's fastest supercomputer. But it's important to note that we're still a long way from having fully operational, fault-tolerant quantum computers. Right now, these machines are being used mostly for research, but the progress is promising. Quantum computing in the future. The potential of quantum computing is vast, but it's not just about faster computers. It's about unlocking new possibilities in science and technology that we haven't even imagined yet. In the coming years, quantum computers could solve some of the world's most pressing problems: climate change, energy efficiency, and more. And the best part? We're only scratching the surface. As quantum technology advances, we could see entirely new industries emerge, completely changing the way we live, work, and interact with the world. Quantum computing is a thrilling, mind-bending field of science that promises to reshape our world in ways we can't yet fully predict. While there are still many obstacles to overcome, the future of technology is quantum, and it's on the horizon. Thanks for joining me today. Who knows, maybe one day, you'll be part of this incredible journey into the quantum realm. Until then, stay curious.